Okay, let's see. They're going to pull my charts up here in a second. Oh, wow. Hey, that's quick, right? Good job, guys. Okay, so sorry. They reshuffled things a little bit. I parked in a terrible place and feel like I ran here from Mars. But let's see if this works. All right, that's the laser pointer. That's functional. All right. Okay, so I appreciate the very kind intro, Dr. Zubrin. So this is what I'm going to talk to you guys a little bit about today. Who I am, how I ended up here, what I'm doing here. And that's really not so important, except I think it kind of ties into the broader theme of what I wanted to talk to you guys about today. I'm going to provide a little bit of a policy view on how we get to Mars, or at least I would say kind of lessons learned that I've gathered over the last few years to share with you guys. I'm going to do a little bit of a deeper dive into the Congress and particularly the Senate, so that's where I work. I'm going to talk about a NASA bill that the Commerce Committee just advanced just a few days ago, so it's very timely to what you guys are talking about now, and there's some interesting content in there as it pertains to exploring Mars. And then hopefully I have time for questions. I doubt I'll have time for answers, though, so sorry about that. Yeah, that wasn't that great of a joke, but thanks for laughing. All right, so who am I? So this chart, these are really actually not in any particular order, but I did want to tell a little bit of a personal story. So the Pathfinder rover landed on Mars when I was a senior in high school, which probably looks like it's maybe in about the middle of, looks like we got folks that are quite a bit younger and folks that are a little bit older. So, but this is the first, this is actually the first thing I did on my computer. So I was going to go to school at Virginia Tech for engineering. And one of the things that you had to do was you had to buy we got a Hokie in the back of the room. Go Hokies, all right. So one of the things that you had to do is you had to buy a computer if you're going to be an engineering student. So I bought it was a Pentium 1 100 megahertz computer, hooked it up to the internet. My family hadn't had America Online or CompuServe or anything, so this was like my first experience on the internet. And I saw, on the news, they talked about this mission, and they were showing some pictures, and they gave a web link, and you had to write down the web link in order, this long link, and I, somehow got it right, and I downloaded these pictures from Mars, and I was just absolutely floored. I just loved the space program since I was a little kid. Probably like 3/4 of the room wanted to be an astronaut, and it was just unbelievable. To all the pictures that I had seen from Mars and from the other planetary missions just seemed so old, and there just really wasn't a whole lot that was new about them. And here we had these just gorgeous pictures of Mars, and I was actually able to get on my computer and download them and watch them kind of downlinking onto my screen as if I was in mission control, and these images were coming down. So really excited. I took a little run at going to the service academies, but I ended up not doing that, and ended up deciding, well, I don't know if this is going to work out, if I'm going to be an astronaut or not, but if I can't be an astronaut, I'd at least like to design and build spaceships. And so I went to Virginia Tech and I studied aerospace engineering, and I got I got to about, you get your freshman and, statics and dynamics, and then, you get into your sophomore year and D-forms and maybe like intro to aero. But the aero program at Virginia Tech at the time was pretty aeronautics focused, especially for the first couple of years. You didn't really get a lot of space content. And they're like, what am I doing? This stuff it's really not that exciting. I'm not doing any interplanetary anything. I'm just running, CFD codes and other kinds of aero things, and maybe some of the statics. I don't know. It's just not that interesting. So I took a co-op with Honey. At the time, it was actually Allied Signal, Greer Repair and Overhaul. They do repair and overhaul of gas turbine engines. I did my co-op here, and I did Lean and Six Sigma with them, and so I really got exposed to more of the business side of engineering, how to take these product lines and actually how to find ways to to convert that into value for the company and to get rid of waste. And I really actually got really interested in that. And so I kind of decided to leave the space stuff behind. I just didn't seem like it was ever going to be real. The space station program was kind of getting started, but it was running real slow. I think the Zarya module and Unity were up, but it was unclear if anything else was ever going to get up. And it's always, talk about overruns and how it's going to get canceled, just like everything else does. And so I just kind of lost interest. And then, so when I was a junior, I did take a couple of spacecraft-oriented classes, and there was a flyer up for a talk at the Student Center. And I didn't usually go to these kind of talks that were the more kind of academic things. I kind of reserved my spare time for other pursuits at that point. But I was like, this is cool. I'll go hear this guy talk. He's going to talk about Mars. Mars is cool. I still remember seeing those pictures from Pathfinder. That was really cool. So I go to this talk, and it's this kind of like little crazy, but really passionate, enthusiastic guy. So it was Dr. Zubrin, and he's talking about the Case for Mars. This is around the time that the Case for Mars came out, the book. And he's talking, and what I loved about what he was saying wasn't just the passion that he had for going to Mars, but the absolute disregard he had for all of the reasons that people said that it couldn't be done, right? Just absolute disregard for anybody. If there's a reason why it can't be done, he had a reason or 5 reasons why it could. And I just found that really inspiring. And so that was actually kind of a little bit of a turning point for me, where I actually started, maybe there's something to this, and I actually ended up taking a bunch more spacecraft design classes, and I ended up applying to every single job at NASA that I was possibly qualified for, and several that I really wasn't. And I ended up getting a job. This is actually a really long story, but the short version is I ended up getting a job at Kennedy Space Center, and I went down to work on the International Space Stations. This picture is a little bit washed out, but this is a picture of S3 and S4, the trusses. So you got S4 was the power module with the batteries and solar arrays, the beta gimbal, and then you have the Sarge over here on S3, which is what rotates the solar arrays around the alpha angle. And so that's one of the integrated truss assemblies that I worked on. And so I just got to spend 4 or 5 years at Kennedy crawling around on this hardware and seeing what it really takes to make this hardware come together. Because that's what, kind of the thing that happens at Kennedy Space Center is they kind of get all the hardware to whatever point they can kind of get it to, and then at some point they just say ship it to Kennedy, and then it shows up to us with like a box of parts and some drawings, and we got to figure out how to actually get the thing put together and launched into space. So that's what I did for a while, and then I found out we were working on this program. This new program was coming around to put people on the moon and eventually get people to Mars. I was like, well, I want to be a part of that. So I moved over to the Constellation program. That had its issues, fairly well documented. Probably some of the myths out there are true, some of them aren't. But at any rate, I ended up transitioning into the SLS and Orion program, and then I also started doing some work looking at how we could take. The SLS and Orion program does not use anywhere near the infrastructure that the Space Shuttle program used. Space Shuttle program used 2 launch pads, 4 VAB high bays, 3 orbiter processing facilities, 3 mobile launch platforms, and we'd scaled down to basically 1 of everything for SLS to save costs. So we had all this extra infrastructure. So I did some studies with a bunch of different companies to look at taking some of that infrastructure and allowing some traditional suppliers and other kind of emerging space companies to come and take advantage of that infrastructure. So I got to work with SpaceX and a couple other companies. And of course, as you guys know, SpaceX has got is leasing Pad 39A down there at the Cape right now. And somehow in all of that, I ended up getting loaned up to Senator Nelson's office, which is, I would say, fairly unusual for kind of somebody of my background to be sitting in some sort of policy position up here in DC. But that's what happened. I did that for a year, then I went back to NASA, and then the person, the permanent professional staffer that I was working for left. and they asked me to come up on a full-time basis. So that's how I got here. So the point of that whole story is, number one, this organization made a big impact on me, and I think that's actually part of why this organization exists, right, is to make those kinds of impacts. And so I can tell you, at least for a sample set of one, it worked. And the other thing is that I'm not kind of your traditional policy staffer, right? I'm a little bit different than your average person who comes into a position like this from more of a political science background or something like that. My background is aerospace engineering, and I'm actually relatively new to the policy stuff. All right, so let's talk about how we get to Mars. Engineering, right? F equals, I mean, anytime you, everybody who's an engineering student knows you got some sort of problem on a test and you don't even recognize it, but you want to get partial credit, right? And so, you know, the first thing you do is you just write down, well, F equals MA, and then you see if you can work your way somewhere from that to something that looks like the answer to the question, right? But there's a reason for that. I mean, this equation makes a whole lot of sense, right? So what we got to do is we got to balance the forces, and we got to do that in a way that gets us the delta V that we need, for lack of a better word, to get us to Mars. So this is an analogy, but I'm going to use this analogy if you guys will humor me on that. So we know what this kind of looks like, and we know how to affect that, right? We've got some knobs to turn on this size in terms of the kind of mass of whatever it is that we got to send to Mars. We've got, we can play with ISRU, we can play with, propellant production on the surface. We can kind of maybe cut some corners or take some risks when it comes to maybe crew radiation exposure. We can use advanced propulsion to reduce the, yeah, I see some heads nodding. Bad idea, right? Okay, I'm not saying we should do that. I'm just saying we could. We can go with some advanced propulsion systems to reduce the amount of propellant that we need overall to get us there by kind of increasing the efficiency. So we got some knobs to turn over on that side. But on this side is what I want to talk about a little bit. So what are the forces, right? So there's the technical part, right? And so the technical part is, kind of the rocket equation, right? And there's actually more equations than that we have to solve, right? But that's illustrative, right? But then we've also got these economic and these political forces, right? And we engineers, we always want to kind of go back to this part of the equation. We always want to go back to solve the technical problems. It's just, if we could just get the technology right, if we could just come up with a different technical approach. And you can do that, but these other terms don't go away. You just end up having to balance them a little bit differently. So the way that I kind of, just for the purposes of talking about it today, is saying, okay, well, if we want to get there, we've got to take these technical forces, right, and we've got to take these economic forces, and we've got to take these policy forces, and we've got to somehow get that net positive that we need to get to Mars, right? So I kind of have some pictures here because I just want to show that there's some very different ways that you can do that, right? So in the Apollo program, it was pretty big on this and real big on this and not so much on that, right? So you had just a massive amount of unsustainable spending that went to invent a bunch of new technology, which was largely for political purposes that actually had very little to do with exploring space. There were broader national interests that were at play there. This is the COTS program, and this is illustrative of, I think, a very different model than the Apollo program, where you had a little bit different balance, a lot more of a focus on this kind of economic term here. And there was some kind of important political things going on here. And there was some interesting technology that went into that. But largely, a much larger focus on this economic term. It was really kind of viewed as this partnership model, right? And then you have down here, this is just not anything specific. It's just meant to be illustrative of a more of a global geostationary kind of satellite. That's all about this term and this term, right? There's some regulatory stuff in this term, but it's really just all about making the technical case meet the economic case. So let's see. Okay, so I just got told 5 minutes, right? Okay. So I'll try to squeeze a half hour that I was planning for into 15 minutes. Okay, so I'm going to go through this really fast then. So bottom line, you have, if looking at that policy side, you've got executive policy, you've got legislative policy. On the legislative side, you've got authorizations and appropriations. Again, this is really quick. You guys will have to go on Wikipedia and read a little bit on your own on this. Okay, so on the legislative policy side where I live, you've got these authorization bills and committees, and they focus largely on long-term goals, long-term spending plans. Example would be the Space Act of 1958 that established NASA in the first place, or the NASA authorization of 2010, and the appropriations committees that focus largely on just year-to-year spending. And both are important, but for kind of different reasons. This is a really important concept in the Senate. The majority of bills that pass the Senate actually pass by the unanimous consent process, and an even larger percent actually involve that same process for intermediate steps, and space bills almost always fall into this category. So generally, when legislation on space policy passes in the Senate, with the exception of some of the appropriations bills, but generally any policy bills that pass the Senate are via the unanimous consent process, which means that 100 senators have to support passage of that bill. All 100, not one of them can object. And it's not hard for them to object. They can just place a hold on the bill and it's unanimous and nobody even knows who it was. So the keys there is that it has to be bipartisan. You got to have some champions who really help you overcome those obstacles. You can't have anybody who just absolutely hates it, because anybody can hold it. You got to make some deals, and there has to be kind of something in there for everyone. And that's a little bit of an explanation of how we kind of end up with the policy frameworks that we end up with some of these NASA bills. So it's not just a question of getting a few key members to support it. That helps. But ultimately, you have to have, in the Senate anyways, the support of 100 senators. All right, I'm going to go really quickly through this. We have a bill, NASA Transition Authorization Act of 2017. It does contain an authorization of appropriations. It largely just tracks with the appropriations bills. Talks about deep space exploration, SLS, Orion, Habitat, but also these industry, commercial, academic, international partnerships and a stepping stone approach to Mars. Deals with LEO commercialization. Deals with some of this long-term monitoring and treatment of some of these spaceflight effects. Has Mars 2020 sample returns, some advanced propulsion, space technology stuff, collaboration. This talks about kind of uniting the science and spaceflight, human spaceflight goals. So this is something I wanted to highlight. So one of the things that's really unique about this bill, now this bill has advanced from the Senate Commerce Committee and soon we'll be looking to actually advance it through the whole Senate, and the prospects look pretty good. But look at these long-term goals that are in here. So I talked about authorization bills having a focus on long-term goals and objectives. And I just want you guys to think about the fact that this bill is something that a large number of senators on both sides of the aisle very strongly support. And if we get it through the Senate by unanimous consent, which I hope to have done, you'll have 100 senators that are signing up. And I just want you guys to look at this language where it talks about expanding a permanent human presence in Earth orbit. That's actually already in code. But we've added this peaceful settlement of a location in space or another celestial body and a thriving space economy in the 21st century. And we've added specifically to achieve human exploration of Mars, including the establishment of a capability to extend human presence, including potential human habitation on the surface of Mars. So as a junior in college, when I was sitting there listening to Dr. Zubrin talk about the prospects for going to Mars, and we couldn't even figure out if we were going to get the space station built. I think it's pretty amazing that we've advanced to where we are now, that we have such broad support behind these types of objectives. And a lot of that has to do with the efforts of folks like you. So what I'm going to close with is do you guys recognize this picture? It's probably kind of washed out, right? I know there's a couple of people. So this is the hint, right? That little dot is blue, right? So this is a picture of Earth taken from Mars, from a rover. To me, this is really represents a picture of everything that and I think a lot of the people in this room have worked for and really dedicated our professional and personal lives to. And so to me, this is kind of a picture taken from our future. It's a picture that I could see being taken by a gloved hand by a person standing on Mars. I kind of like to wonder what this person is thinking. Do they kind of feel like they're in this strange, hostile place, or do they feel like they're more of a settler on a new frontier? Do they miss their home? Or do they kind of wonder if this place could be their home? And I really wonder what the people back on Earth who download this picture on their computer the same way I did when I was looking at my Pathfinder images, I wonder kind of what they think. How this makes them feel, does it make them feel proud? Are they curious? Is that a place that they want to go? Is it a place that they feel that this is something that we did together? And somehow by going this huge distance together, it somehow has brought us actually on Earth closer together. So I hope to someday to see this, and I hope it's not too far from now. And if this happens, it's going to be largely the results of the efforts of people in this room and others who are doing the stuff that you're doing. So if you want to come talk about some of this from a policy perspective, I have a lot of stuff that I skipped over, but the Hart Senate Office building is a public building. My door is open. Come talk to me. You don't need a lobbyist. You don't need you can just, call our number and just say, hey, I want to come and talk to Nick about space policy and how we make this happen. So thanks very much.